What's up, everybody? You have the distinct privilege today of watching a master at his craft. Okay, I am going to go through the expressions review answers. Any of these problems that you did not get correct on your review, thumb through the bottom here, pick the questions that you missed, watch how to solve them because you got to be ready for that test tomorrow. And if you still have questions, make sure you talk to me or your teacher to get it straight. Here we go. Number one, Sammy scored 6 points more than 10 times the number of cards in his hand. C represents the number of cards. Obviously, C stands for cards, but we don't know how many that is. So we need a expression for the situation. Well, 6 points more than, I know I'm adding 6, right? More than means to add. And then we're adding 6. 10 times the number of cards would be 10 times C, right? It literally says 10 times that number, 10 times Z. There's no what it is, so we use 10C. So we have 10C plus 6 more than that, so 10C plus 6. That's one right here. Number 2, based off the answer from number 1, if he had 8 cards in his hand, how many points did he score? And the answer from number 1 was 10C plus 6. So all we have to do is put an 8 in for the number of cards where the C is, and that's just called substitution. Stick in an 8 there, and then follow your order of operations. 10 times 8 is 80 plus 6 is 86. Number 3, the width is 20 feet less than the length of the side. You might recognize some of these questions. I've used them in my reviews before, but we are expanding on it. Length of the side is used by S. 20 feet less than the length of the side. Well, if the length of the side is S, we know what that is. I need 20 feet less than that, then I will subtract 20 from it. Okay? And the way I would show that is S minus 20. Definitely not 20 minus S, because that would mean I'd be subtracting the length of the side. It does not say to do that. It says to find 20 feet less than that, not S less than 20. Number 4. Based off that answer, where we had S minus 20, right? 20 feet less than the length of the side. If the length of the side is 85 feet, what's what? Right? So we take 85 and just plug it in here using substitution. And 85 minus 20 is 65. So the answer is 65 feet. Number 5, one of my favorite ones. Write an expression that represents 1/4 of x. To find a fourth of something, very similar to find a half of something. If you're finding half of something, you divide it by 2. If you're finding a third of something, you divide it by 3. If you're finding a fourth of something, you would divide it by 4. So what we need is a fourth of x. So we need to divide x by 4. And the only one of these that shows x being divided by 4 is this one here, because we know that fractions are division problems. X divided by 4 is what that says right there. Based off that answer, evaluate if x equals 12. And again, we will just use this expression. We'll plug in 12 where x is. Looks like it's on top of that fraction. And you get something like this, which is 12 divided by 4. 12 divided by 4 is 3. Number 7. Write an expression that represents 5 subtracted from, easy, right there, we know it's minus 5. This 5 is being subtracted from it, so that's minus 5. From 10 times the number of cookies, where C is the number of cookies. We don't know what the cookies are, so we use a letter, C. And 10 times that, easy. 10C, and then we subtract 5 from it. So 10C minus 5, there it is, right there. 10 times the number of cookies, 5 subtracted from it. Right. Identify the coefficient and constant in this expression, 5y plus 7. I know that a coefficient is the number in front of a variable, so the coefficient is 5. Constant is a number without a variable, and that's 7. So the two things I'm looking for are the 5 and the 7. So coefficient is 5. These two say coefficient of 5, and this one says constant of 7. So this one's not the answer because it's not the fact that there's no constant. There is one, it's 7. So coefficient 5, constant 7. Number 9, same thing. Identify the coefficient and the constant. In this one here, we've got the coefficient here is a 4. And the constant here, some would say is a 1. But remember, the sign in front of all the terms are kind of tied to it. So this would actually be, since there's no sign in front of the 4x, it's positive. Right? But if there is a negative sign in front of a term, then we say that term is negative. So we would actually say that the coefficient is 4, the constant is -1. Coefficient is 4 and constant -1. Number 10, identify the coefficient and the constant in this expression. This one's a little bit more tricky. We flip them around on you just to see if that would confuse you a little bit. But remember, coefficient is a number in front of a variable. It's being multiplied by it. It's literally got to be touching it. And this 3 is not. Right? This 3 is not a coefficient. There is nothing in front of the x here, you can see. But when there's nothing there, we say there's a 1 because they're being multiplied together and anything times 1 is itself. So we'd say the coefficient is 1. And since the 3 does not have a variable with it, it's a constant, 3. So coefficient is 1, constant is 3. Identify the terms in this expression. The terms are anything separated by addition or subtraction. We've got a 5x, we've got a 4, and we've got a 6x. There's 3 terms here. So either one of these, and it's 5x, 4, and 6x. These are the 3 terms. Number 12. Identify the terms in this expression. We've got a 7x, one term. We've got a -8, and a 2y. So we've got 3 terms. 7x minus 8 and 2y. The only one that might confuse people is they pick the positive 8, but remember the sign in front of the term is tied to it. So we will say that's a -8. Number 13, evaluating an algebraic expression where you've got to take the number and substitute it in for the letter. So 30a minus 2b plus 6. If I tell you what a and b are, all you do is put them in there. And remember, when a number and a letter right next to each other, it means multiply. So we're going to do 30 times 2, 2 times 5. But what we're going to do first is substitute. Got to write them in there, guys. It's so important. I'm going to rewrite the problem. 30, 2 goes in for A, minus 2, 5 goes in for B, plus 6. Now I'm going to follow my order of operations and solve this problem. Multiplication, subtraction, multiplication, addition. The multiplication is going to come before the addition and subtraction, and the addition and subtraction are going to get done in order from left to right. So make sure I follow my rules here. 30 times 2 is 60. Next, I will do this multiplication. 2 times 5 is 10. And then my addition and subtraction will go in order from left to right. 60 minus 10 is 50. Plus 6 is 56. Number 14. Number 14. If x equals 2, y equals 3, find the value of 7y squared plus x, or 7y to the second power plus x. And if these are a little bit confusing to you and you're still not substituting in parentheses, that's your own fault. Okay? Because I've been telling you this whole time, and I'm sure Miss Edwards and Miss Blackstone have been saying the same things on the other side of these walls. You got to substitute, and it's got to be in parentheses every time. And it's going to make these a lot easier on you. So I'm going to put in a y as 3, so I'm going to put 7, put my 3 in where the y is, with the exponent there, plus, and then my x is 2. I'm going to plug that in there. So now what I've got here is a 3 to the second power. I've got 3 being multiplied by 7, and I've got a 2 being added. So according to my order of operations, the exponent will get taken care of first. 3 to the second power is 3 times 3, not 3 times 2. 3 times 3 is 9. Put a 9 there, and we know that's getting multiplied by the 7, so I'm going to keep it in parentheses. And we have to add a 2. Okay, so first I'm going to multiply. 9 times 7 is 63. Plus 2 is 65. Number 15, we have to evaluate this expression here. 2 to the 4th power divided by 4 plus 6 times 3 minus 11. So quite a few things going on here, but again, if you do one piece at a time, you follow the rules, you'd be just fine. I'm going to write it right over here so I have more room. 2, 4, 4, 6, 11. Okay, so the first thing I'm going to do is take care of parentheses. So some people will say that's parentheses. I say no. I say that's just 6 times 3. So we're going to move on to exponents. There is exponents, 2 to the 4th power. That is 2 times 2 times 2 times 2. Let me see if I can do this here. 2 times 2 is 4. Times 2, 8. 8 times 2, 16. So that means 2 to the 4th power, 16. I'm going to rewrite this. Keeps me organized, makes sure I don't make a mistake, and if I do, I'll be able to find it. So I've got division, addition, multiplication, subtraction. So I'm going to be taking care of the division and multiplication first, but I'm going to take care of it in order from left to right. So I'm going to do the division and multiplication in that order. 16 divided by 4 is 4. Now we do the multiplication. 6 times 3, 18. Just rewriting the rest of the problem. Now I only have addition and subtraction left, so I'm going to go from left to right and continuing this process. 4 plus 18 is 22, minus 11. The answer is 11. Next, number 16, we've got another really good one here. And I'm going to write it off to the side here, make sure I have enough room. So none of you guys have an excuse not to write these. If only Mr. Johnson can do it. Schreider, whatever my name is. Okay, so we have an X here. Not a fan of this. I don't know how that snuck in here. I must have missed it, but I'm going to go ahead and just put parentheses around it. So we've got a multiplication problem, so we're not confused. We don't think it's an X, right? So we've got exponent, division, subtraction, multiplication, and addition. Very similar to the last one, right? No parentheses to do in this one, but we do have an exponent, 10 to the 2nd power. 10 times 10 is 100. Divided by 2 minus 7 times 3 plus 9. Next up, division and multiplication will be taken care of. I'm going to do it from left to right. 100 divided by 2 is 50. 7 times 3, 21. Now I can subtract or add first, but if there's addition subtraction, I have to do it in order from left to right. So we'll subtract first, and we'll get 29 plus 9, which is 38. Next up, number 17, factor the expression 20y minus 24. Now remember, factoring is where you find a common factor between the numbers and you pull it out. It's like undistributing. So what I would do is I would find a common factor here between 20 and 24. There are several actually. It looks like between these answers here, it could either be 4 or 2. I think the bigger one is 4, so I'm going to factor out 4. And whatever's left from these, after I divide them by 4, will be what goes inside the parentheses here. So 20y divided by 4, well, 20 divided by 4 is 5, and we know the y is going to stay. And 24 divided by 4 is 6. So we should be seeing 4 times 5y minus 6. And that's an answer right here. And again, you can check that answer too to see if it's correct. 4 times 5y is 20y. 4 times 6 is 24. So that is our answer. Number 18, factor the expression 27x plus 21y. All of the answers here show 3 being factored out. So let's go ahead and start there. Let's just factor out a 3 and see what we get. 3 times what would give me 27x? 3 times 9 is 27. So make sure we have our x there. And 3 times what would give us 21y? 3 times 7 y would give us 21y. So it looks like I factored out 3 and left with a 9x plus 7y, and looks like this is my answer. Number 19, our work with equivalent expressions and combining like terms here. So we've got 3 terms. 2 of them are like each other, which means they can be combined. We've got a 5x and a 7x, and 5x's and 7x's together will give you a total of 12 x's. So that's 12x. And then we have a 6y. And y's and x's cannot be combined together because they're not like terms, right? We don't know what they are, so we can't add them together. We can't show them as multiplication like we can with 12x. So we just had 12x plus 6y. So as far as we can take that one, this is our answer right here. Number 20. Write this expression in simplest form. Again, combining any like terms that we can. We seem to have 3 like terms here, 1b, 10b's, and 12b's, all being added together. And when you have that many b's being repeatedly added together, we can just show it as one big multiplication problem. Instead of doing b plus 10b's plus 12b's, we would have 22b's plus another b is 23b, so we'll say 23b. And then we have a 19 here, and this 19 cannot be added with all those b's. It's just a regular 19, so 23b plus 19. And I don't see that here, but I do see a 19 plus 23b. And good thing for us, the commutative property says that this and this will give you the same answer because it doesn't matter what order you add in. So next up, we have a distributive problem here, but we have three terms. So we could technically do this two different ways. You can, inside these parentheses, follow your order of operations and combine terms inside there. Because the 3a and the a are like terms, you can combine those. And you can go ahead and say that this is 4a plus 6 inside here, which might be a little bit easier. I'll show you both ways. So if you do that, and you left with 7, these are the same thing. Because 3a plus this other a in there makes 4a's inside the parentheses. So we just write it as 4a together. But we still have the plus 6, right? So then you can distribute. Right? 7 times 4a is 28a. Plus 7 times 6 is 42. So we could get 2a plus 42. Now the other way to do this would be to actually distribute to all three of them, which is possible. It doesn't matter how many you have in there. So you could go 7 times 3a is 21a. Plus 7 times 6 is 42. And then you have 7 times a, which is 7a. But as you can see here, now if you combine the terms, 21a and 7a are like terms. You can combine those to make 28a, and then you still have your 42 there. So either way you do it, you get the same answer. The answer is 28a plus 42. Number 22, use the distributive property to show an equivalent expression. Again, here, just like we did up here on this one, we're going to distribute because we cannot do 6y plus 9 inside the parentheses. You just can't do it because they're not like terms. Can't combine them. So what we can do is actually distribute the 5 from the outside first. So 5 times 6y right here, the first one, will be 30y. And 5 times 9 is 45. So we get 30y plus 45. And again, another problem where they're switched around, but commutative property says that this is still equivalent. Number 23 is a fun one because we want to be able to combine like terms, but order of operations says we got to do with parentheses first. But we can't do parentheses first. So we can't do parentheses first, we got to get rid of them. And how can we get rid of the parentheses? We can distribute. Okay, so let's go ahead and do that first. Let's go ahead and distribute, and then we'll write the rest of the problem around it. So let's go ahead and do 4 times 8x. And 4 times 8 is 32, so we'll say 32x. And 4 times 7, there's an addition sign in between, right? 4 times 7 is 28. Now, remember the plus 9 in the front and the plus 7x in the back there. Now, what we've done is gotten rid of the parentheses, so we can actually simplify now. A really cool way to show why the distributive property is kind of nice. So now we got to be able to combine like terms. There's 32x and 7x's here, so we can put all those x's together to make a total of 39x's. Right? Combine those two up. And then we have a 28 and a 9. They're just regular numbers. Of course they can be added together. What is 28 plus 9? 37. So we have 39x plus 37. And this can't be taken any further because all these x's cannot be added with the number 37. So long as it's bizarre. So, sorry. Last two problems. Number 24. Write this expression in simplest form. I love this problem. It's got very similar to the last problem I just did, but it's got a fraction in it. So what we're going to do here is, in order to get rid of these parentheses, because you cannot do 12y plus 8, so we can't do parentheses first according to order of operations. So we got to find a way around it, and the distributive property helps us here. So what we got to do is distribute this 1/4 to both of these. And if you're multiplying by a fourth, it means you're finding a fourth of something, which really means you're dividing by 4. So all you have to do is divide each of these by 4, and then that will be your way to distribute. So 12y divided by 4 would be 3y, and 8 divided by 4 is 2. So that's what it means to multiply both of those by 1/4, right? You end up just dividing them by 4. Multiplying by a fourth, the fraction, is really dividing by 4. And if you don't believe me, 1/4 times 12 is just 1/4 times 12 over 1, which gives you 12 over 4. And 12 over 4 is 12 divided by 4, which is freaking 3, okay? So get off my back. All right, so that takes care of this over here, right? So this right here that I have is really just 3y plus 2. Now I can add plus 2y and the plus 3 there. So I've helped take my equation, or my expression, and get rid of the parentheses. Now I can combine some like terms, right? 3y and 2y for a total of 5y's. And 2 and 3 regular numbers, just add up to 5. So 5y plus 5. Great problem. And number 25, select 3 expressions that are equivalent to 6j plus 8k. So what I'm going to do is go through these and see if I can get any of them to be equivalent to this. Let's start here with this one. 2j plus k. Really? Yeah, no way. Those aren't even that close, right? 2j plus k is not equivalent to 6j plus 8k. How about this one here? 3j plus 7k plus 3j plus k. In order to find out if it's equivalent to that, let's go ahead and simplify this. 3j and 3j makes 6j. Ooh, hey, close. And then 7k and another k make 8k. So that actually, this one right here is equivalent. Okay. How about this one right here? We've got 3j plus 4k in parentheses there, and then a 2 outside. We can't simplify it unless we use a distributive property here. So let's distribute the 2 times 3j, which would be 6j, and 2 times 4k, which would be 8k. That one's also equivalent. And this one here, we have a half times 3j plus 4k. Well, half of 3j is not 6j. Half of 3 is not 6, right? Half times 3 does not give us 6. And a half of 4 is 2, so this is definitely not equivalent. This one here, a half times 12j plus 16k, again, distributive property. But 2 multiplied by a half just means to divide by 2, so 12j divided by 2 is 6j. And 16k divided by 2 is 8k. So actually, yeah, that one's equivalent to, that makes 3, but let's just check the last one to be safe. 2 times 4 will be 8j, and no, we're looking for 6j, so no, it doesn't work either. If you guys still got some questions, let me know. All right, good luck on your test tomorrow.